I know this is going to be quite a short video, as the others have been, such as the Suvat equations. Well, I could have done more on that, but I'm assuming you were okay with Suvat equations. There's not much to them apart from knowing them, which are even given in the exam. So personally, I wouldn't spend too much time unless you have serious trouble with them. I'd spend more time, like me, I'm going to spend more time on motion graphs. And I did okay, but there's always room to improve on them. So the one we're going to do now is acceleration. It's only going to be a small bit because you should know acceleration. There's just a few little bits that I've had on exams and it's caught me out a few times, so I thought I'd help you. It might catch you out. Stop exactly as being idiots. So obviously you know v equals u plus at, and then we can rearrange that to get a equals delta v over delta t, and that's how you get your acceleration formula. So as I said before, the gradient of a speed time graph, or the acceleration, speed time graph is the acceleration. Yeah, so for an object moving at a constant speed on a radius, so for example a satellite orbiting the Earth, you might need to know its velocity. You can know this by v equals 2 pi r. Oh, that's not the power of r, that's just times by r over t. So you may be asking, well, what's t? Well, t is the time period for it to get round the Earth once. For example, if it was a satellite. And v is the velocity, r is the radius, and obviously pi is 3.142, etc. So, yeah, that is the velocity for it when it's going round, assuming it's a constant velocity. So therefore the acceleration would be zilch, 0, square root of jack, diddly boom, bom, bom, 0. So you might get asked something, a change in speed. So we know speed equals distance over time. This might seem a bit babyish, but I just want to make sure that you understand it. No offence, of course. So, speed, I can't do motion graphs, so I can't really speak. Even though you've learnt from me, which probably doesn't sound so good now. So, speed is distance over time. Now, for an average speed, you need the yeah. Oh. Yeah, you know, the average speed. Yeah, the average speed is distance over time. Now, if we wanted to know the right, so that's. Oh, I thought I had some other equation there. So speed is distance over time. It's just that's an average speed. It's not the speed that it goes up. Yeah, that's pretty much it for the acceleration. Oh, you've two types of acceleration, sorry. You've got uniform acceleration. Well, acceleration is defined as the rate of change in velocity over a given time period. So, there's two types of acceleration. Just speed, time, no. Just give me a minute to draw the graph, speed and time. You've got two types of acceleration. You've got uniform and non-uniform acceleration. Now, uniform acceleration, you may be asking, what is that? Well, uniform acceleration is where the object is at a constant acceleration. But So, for example, you could have, so as we know, speed equals distance over time. So that means, yeah, the speed time graph is acceleration gradient. If that makes any sense at all. Yeah, because this is V and this is T, and A equals delta V over delta T. So V over T equals A, if you follow that. So that is a straight line that represents uniform acceleration. However, non-uniform does that. Or it could do anything. It could do this. Probably not a loop, but you get the faint idea. So linear. When I say linear, I don't mean like linear. I mean perfectly straight, perfect linear, perfectly linear, absolutely linear. So that is a straight line. So let's put uniform and not uniform, or not non-uniform, doesn't matter. It's not uniform in Europe. And as a school, it is uniform acceleration. It's constant or not constant. Right, so that's pretty much it for acceleration. I hope you've got that, and we'll see you in the next video.